What's up guys, welcome back to Vanover Customs. In today's video we're going to be making a follow rest for the American pacemaker lathe. We're currently working on the Lion lathe project and I do need to make a new lead screw, and a follow rest would be perfect just to make sure we can get this shaft made without any distortion and nice and clean and minimize chatter. We're going to bring you over to the lathe and start the build process. We're over here at the carriage and let's talk about the way that the factory follow rest is installed. So the factory unit bolts with 2 bolts here, and then there's usually a tapped hole down here, and it saddles across and bolts down here, and it comes up like a C and is a follow rest. Now obviously buying one, way more ideal, but as hard as it is to find a steady rest for this lathe, which it is, it's even more difficult to find a follow rest. So yes, I've looked, I can't find them, I'm not going to waste any more time looking, and I need one rather soon. So we're just going to build one. So the method we're going to be making for this is pretty simple really in terms of design. What I'm going to do is start by drilling and tapping a hole down here, and we're going to do a weldment where it saddles over the actual top slide here, and then there'll be a plate that comes and contacts with the weldment. That way we have 3 points of contact, and then in that we're going to cut out a little C, install a pipe, and then add our 3 actual contact points that we can adjust. So the first step is to come in here and drill a hole on the carriage because there isn't one currently, and then get that tapped. All right, off camera I went ahead and made a cardboard template. It's kind of like a mock-up so we can kind of see what we're doing. This is the design we're going for. I seen a design like this, I think it was Winky's workshop. He had it was a much smaller lathe, but I really like the design and the concept. It really relies on a piece of flat plate as the backbone, and when you stand plate up in this orientation it has a lot of strength, and then we'll take the strength of pipe, which I have right here, a scrap piece of pipe which has its strength on a radius, and we'll put this in here and we'll weld around on both sides, and then that pipe will give us the spot we need to mount our adjusters. Wow, that's looking real nice. Real nice. Made this piece off camera, real simple. Just a piece of 5/8 plate with a tapped hole. We'll get that threaded down. Another piece of 5/8 plate here. Seems a little overkill, but that's what I want here. Rigidity is a priority. I don't really think this needs to be crazy rigid, but I have the plate, might as well. So we got all this tacked in place, and I just want to address something very obvious here. Welding on a lathe is not something that is recommended, and the only reason I'm going to do it in this case is for alignment. So I went ahead and ran this up against the chuck, and this piece is perpendicular to the chuck within like 1/1000ths, which is way good enough for what we're doing. I am sure it will move when we weld it, but the point is I want to have everything bolted down in all 3 spots and welded as it sits, because it's going to have a much less chance for moving. I have a lot of corner bracing here to try to minimize the moving, but it will move. Weldments always move. And if I unbolted this and took it over to the bench, It would be fine, but most likely I would need to face off the bottom, and just setting it up in the machine to do that would be really difficult. So the best result will be welding it in place, but there's a couple problems with that. The first and most obvious is you're not supposed to weld on a lathe. Why? Two things: electronics, number one, and number two, bearings, right? If you're welding and you don't have a good ground, it can go all the way through the machine, short out bearings, cause bearing damage. So if you're gonna do it, the most important thing is make sure you have a solid ground so that the ground is grounding right here instead of trying to go through the machine. So that's the first consideration. We'll put the ground on raw steel and make sure we have a good ground. Additionally, I have the machine unplugged and I have the DRO completely unplugged so that there's nothing on in case there's any frequencies or anything that messes with it. So that should help with that. And then third is the ways in the machine. I currently have the ways covered with a fire blanket on one side and some wood that's damp on the other, and then some steel in underneath to try to minimize any weld that falls down. And then I have some anti-spatter sprayed across the lathe. Now this is water-based. It will rust the machine, but it's in an area where I can easily wipe it off when we're done. So I'm trying to take as many precautions as possible to try to get the best result. So we'll go ahead and get this welded out. I got it all tacked with short circuit because it's nice and easy. I am going to come in here and use dual shield with my new machine and try to get some really nice penetration on this 1/2-inch plate. All right guys, we got this fully welded out. I did 2 passes in some areas. Some areas just got 1 pass. Looks pretty good. Penetration looks great. We're just gonna let this cool for an hour or so and come back. Once it's cooled off, I'll unbolt it and then get it out and get it cleaned up. It's interesting how oddly satisfying that is. It seems to be fine. I'm just gonna take it slow. It's going good. I'm half tempted to speed it up, but there's no point. I'll just take it easy. There she is. Look at that, what a beautiful cut. What a great saw. Which means that it is like the perfect size. And I'm not gonna touch it because I don't wanna make it bigger or smaller. Probably one of the most difficult parts of this build is making these adjustable fingers. So I sat down to design them and I realized the best thing to do would be to go take a look at a steady rest that I have and see how they design them and make some adaptations to their design or copy it. And when I came over here, I realized that I have 3 of these things. I purchased all 3 for my big lathe and I really only need 1, but I got all 3. And so instead, 1 or 2 of these are scrap basically. What I'm going to do is I'm actually just going to steal the arms from one of these and use them to make mine. Off camera, I went ahead and cut and faced 3 of these tubes. As you can see now a little bit easier how nice of a fit this is going to be for our fingers. And that's without doing any machining on the inside, so that's really nice. Then we'll press the back caps into the back. There's a little bit more friction here, so it'll be a nice press fit. And then we'll either do a set screw like they had before, or we'll do a TIG weld, plug weld, and then the screw will be able to come right through. Next step is to take these over to the milling machine, and we're gonna pop a hole so that we can press a stud in there so we have a place for our adjusters. Make sure it looks square, and then we'll give it a good press. Turned out really nice. So what we'll do next is I'll get these cleaned up on the inside, and then we'll tap these holes for these bolts and move on to the next step. Just taking a cleanup cut. Once it finds a home, it will be more stable. We just got this fresh off the milling machine and deburred everything. Turned out really nice. All of these holes are about 2 to 3 thousandths undersized from 2-inch, and these rods or tubes are about 1/1000th oversized. So that's between a 3 and 4 thousandths press fit. Probably a little bit on the high side in terms of a press fit, but what my hope was is that we have a nice tight fit, so that way when I go to tack weld these, they don't move on me. So what we're gonna do is stick these in the freezer for 30-40 minutes while we take lunch, and then when we pull them out, we'll hit them with our special chemical to cool them off another 20 to 30 degrees Fahrenheit. Then we'll preheat this ring, maybe 300-400 degrees, and hopefully between 400 degrees here and negative 20 or 30 degrees here, we'll be able to make the size difference such that I can just slip these in. All right, here we go. All right, that's a good sign. All right, that's not a good sign. There we go. Little run at it. There it is, boom, look at that. All right, we're ready to press these heads on. It's a 2/1000 interference fit, and I know it's gonna work well because it's bronze, has a lot of give, so it should be no problem. Still tight. I went around and just honed the bores of these. When you weld this, the dimension's gonna change. So now that these slide real nice on all three of them. So the next step is to take these end caps and to press these on. They should be like a 1/1000 press fit, if that. And then originally they were held in place with a grub screw, but probably what we'll do is just drill a hole and then do like a little bit of a weld. So let's just tap these in. All right, so that's that. And then the screw will come through and then pull this up into here, just like that. We got everything finally dialed in and everything's working really, really nice. All that's left to do is get everything painted, but here's the proof of concept. We got our adjuster bolts with the little finger on the end so that it can keep everything lined up. And we were able to reuse the old knobs from the old steady rest as well. So everything turned out real nice. We're gonna give this a coat of paint and then give it a test run over on the lathe. The paint's dry, we got it mounted up in the lathe, and man, this thing looks killer. Not only does it look good, I think it's gonna function excellent. The adjusters adjust nice and smooth. The base is super rigid and it's ready to be put to work. In the next video, we're gonna be making a lead screw for the Lion lathe, and we made this specifically for that purpose. So as much as I would love to show you it working in this video, come back for the next video and we'll see it being put to work. Guys, if you have any questions, post them down below and we'll catch you in the next video.